Beyond the area formula 9.1, we're going to go ahead and apply trigonometry in two more scenarios. The first scenario is going to be with what's called the law of sines. And so what we're going to do is relate sides to angles opposite those sides and vice versa. So we'll take a similar approach as we did with area formula, where I'd like for you to relate the sides of the triangle A, B, and C to the angles by first looking at individual right triangles. So if we focus on the triangle shaded in yellow first, and we look at expressing H and relating it to A, we would use the side of triangle ABC, lowercase c, to relate the three parts. So we get sine of A when we have the height is the opposite over C is the adjacent. And if we solve for height, we multiply both sides by C, we get C sine A equals the height. Let's go ahead and take a similar approach with the triangle now on the right. So if we want to relate H to big angle C with a side of triangle ABC, the only side that's part of this pink triangle is lowercase side A. And so to relate these sides, again, we're going to use sine of C equals the opposite height over the hypotenuse. Isolating the H, we get H equals A sine C. So now we have two expressions where we have that they equal H. And so if they both equal H, then they're going to equal each other. And so we set C sine A equal to A sine C. And now I'd like to divide both sides of the equation by both a side and the sine expression. So from the left-hand side, we're going to divide both sides by C. And actually, let me go ahead and write that underneath the sine C. And then from the left-hand side, or I'm sorry, the right-hand side, we're going to divide both sides by lowercase side A. And then if you notice, the sides cancel out, and we're left with sine of A over lowercase side A equals sine C over lowercase side C. This is the law of sines, where we can relate an angle and the side opposite it. And so what I'd like for you to fill in here, if you haven't already written down how we derive this, is that the law of sines says that, and let me go ahead and use a different color, sine of an angle over its opposite side equals the sine of another angle over its opposite side equals the sine of the third angle over its opposite side. This is the law of sines. It's really nice to have this proportion where we can relate sides and angles opposite them. Looking at this chart, this table, you should recognize this as criterion to prove triangles congruent, ASA, and so on. But now we're looking at, given three pieces of information about one triangle, can we apply the law of sines to solve for missing parts of the triangle? So for example, if we had ASA, that would be like having B and C and then the included side A. Well, if we have two angles in a triangle, we can solve for the third, and then we would be able to complete three parts of one proportion to solve for missing sides in the other two ratios. Similar argument, AAS, we have two angles. We could definitely solve for the third to complete proportions. And then ASS, donkey theorem, if you will. We'll also have enough information to fill out a proportion in order to solve for missing measures. Looking at side, 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 for example, though, you'll notice that if I'm given all angles, I cannot fill out a proportion. I don't have any of the sides to solve for the missing sides. And then similarly, SAS, I don't have enough information in one ratio to fill out a proportion to solve for missing parts of a triangle. So looking at the now you try some, can you identify just from given information if you can solve for the sides of the triangle? So go ahead, pause the video, and then resume when you're ready to compare. Looking at number one, if I am given measure of angle A, side B, and side A, then I have enough information by SSA to fill out a proportion and solve for missing parts. If I look at number two, I have measure of angle B, side A, and C. If you look at the diagram, we do not have enough information to use the law of sines because we cannot fill out a proportion. This is SAS, so that's going to be a no. And looking at the last one, if I have the measures of angle A and B, and I have side C, this is a hidden yes because we can solve for the measure of angle C. Looking at the next page is where we're going to actually apply the law of sines. At the top of this page of the notes, you'll notice that there are three examples worked out for you. The first one is an example of ASA. So given two angles in the included side, solve for the other two sides in the other angle. It's easiest to start with the third final angle because you can just subtract the given 2 from 180. And then from there, I always ask you to look for a fixed side and a fixed angle across from that side so that you can complete a ratio that will keep your math as precise as possible. So in this case, it's sine of C and the side across from it. You'll notice that that ratio is set up in both solving for side B and solving for side A. From there, it's a plug and chug and then solving using proportions. But instead of just rational numbers, now we have expressions using sine. Similar arguments can be made, and if you look at example B, it's AAS, so again, you have two angles, solve for the third. And then if you notice in this one, you have angle A and then lowercase side A are given. So that's the fixed ratio I'd encourage you to use in solving for both sides B and C to keep the math as precise as possible. And then another example of ASA to finish out the examples that are worked out for you. Something to remember in looking at these law of sine problems is that the largest angle is going to be opposite the largest side, and then vice versa, the smallest angle is going to be opposite the shortest side. Let's go ahead and try out an example. We have an example of AAS in this first problem. We have two angles. We can solve for the third. So if we do 180 minus 106 minus 45, I believe we get 29 degrees. And from here, we can go ahead and solve for our missing sides, which are lowercase b and then lowercase a. So that means that our fixed ratio is going to be the sine of angle C over lowercase c, and then we want to set that equal to sine of b over little side b, and then we'll similarly want to use that fixed ratio of sine C over c to solve for the missing side a. And so from here, we substitute values. Sine of 106 over 25. 25 is going to be our largest side because it's opposite the largest angle. And then from there, sine of 45 over b. Cross multiply, we get 25 sine 45 equals b times sine 106. And to solve for b, we need to isolate it, divide both sides by sine 106. And so from here, plug this into your calculator as is. Be sure that when you when you're plugging this expression into your calculator, you close out the parentheses behind the 45 before dividing by the sine of 106. And if you substitute this incorrectly, you'll get b is about 18.39 centimeters. And then we repeat on the right-hand side. So substituting again, sine of 106 over 25 equals sine of now angle A over side A. Multiplying both sides by A and 25, we get 25 sine 29 is going to equal A times the sine of 106. And if we want to isolate the A, divide both sides by sine of 106. Again, be sure that you close out the 29 in your calculator before you enter the bottom expression, and if you plug this in correctly, you should get about 12.61 centimeters for A. At this point, I'd encourage you to take a look at that second example, work it out on your own, resume the video as you'd like to see me walk through it, and then double check your answers for sure. In this example, we're given ASA, so first and foremost, I'd encourage you guys to solve for the measure of angle A, which would be 59 degrees, subtracting the 2 you're given from 180. And then from here, I'm given small side A. I don't have C or B, and so my fixed ratio is going to be the sine of A over side A, and then you'll solve for the other sides as you did in the previous problem. So sine of 59 degrees over 9 equals the sine of 64, for example, over lowercase c. If I multiply both sides to get rid of the denominator, I'll have c sine 59 equals 9 times the sine of 64. Divide both sides by the sine of 59. Be sure that you close out the 4 on the 64 before plugging it in. The denominator, you should get c is about 9.44 centimeters. And then similarly, you'll solve for b. So sine of 59 over 9 equals sine of 57 over b. b sine 59, I'm running out of room here, equals 9 sine 57. Divide both sides by the sine of 59. And if you plug this into your calculator correctly, you'll get b is about 8.81 centimeters.